Welcome to video on linear integrated circuits. So in this we shall see an application of op-amp, which is a stable multivibrator. We know that this is the block diagram of a stable multivibrator. Consists of a Smith trigger and a RC network, which is used for charging and discharging the input voltage, which is applied to the Smith trigger. The input to the RC network is taken from the output of the Smith trigger. When the input capacitor voltage exceeds VTH, output makes a transition from first VSAT to minus VSAT. If input capacitor voltage, the capacitor voltage, if it tries to go below VTL, the output makes a transition from minus VSAT to plus VSAT. So in the previous video, we have seen an astable multivibrator with a single R. So as you can see here, so this will make a duty cycle of only 50%, and we shall see in the advanced circuits, so we can have a duty cycle of any a square wave of any duty cycle. So this is a circuit what we are looking into. So this R1 R2 will provide the positive feedback, which is a part of your Smith trigger. This RA resistor will be on when the output voltage is at minus VSAT, whereas the RB resistor will be on. This diode D2 will be on when this V0 is at plus VSAT. So this D1 will be on during V0 as minus VSAT. So mean to say this capacitor will charges to plus VSAT when the resistor, when the output voltage is plus VSAT through RB. So when the output voltage is minus VSAT, the capacitor charges to minus VSAT through resistor RE, meaning the charging part of the capacitor will be to plus VCC through this resistor RB, while the discharging path will be through RA. As you can see here, if RA is equal to RB, we'll get a 50% duty cycle. Suppose if RB is more, if the resistance of RB is more, the capacitor takes more time to charge to beta VSAT. So that's why the on time is more. The on time will be more than off time if the resistor RB is more than RA. It is the vice versa. Suppose if RA is more and RB is less. Suppose if RA is more than RB, then it takes longer time to discharge. As you can see now, the off time is more. So it will be there in minus VSAT for a longer time than the time during which it will be there in plus VSAT. So meaning to say the duty cycle will be more than 50% if this resistor RB, if it is more than RA. It will be less than 50% if the resistor RA is more than RB. So this is what is the equation. So we are going to get the expression for on time, because it is a time constant C into RB, which is responsible for charging the capacitor to plus beta VCC. So we have the on time given by RB into C, ln of 1 plus beta by 1 minus beta, where beta is given by the ratio of resistor R1 by R1 plus R2. Similarly, the off time is given by RA into C, because when the capacitor is discharging, it will be discharging to minus VSAT of the output through resistor RA and the diode D1. So here in this expression of on time and off time, we are neglecting the diode on resistance. So it's only RA and RB that is considered. Of course, the values of resistor R1, R2, which will decide the threshold voltage. So here there are some examples. Specifications are this is the on time, the corresponding off time. So we are assuming the specification given as R1 is equal to R2 is equal to 1K 1K, and RA is taken as 100 kilo ohms, and RB is equal to 12 kilo ohms. The value of C is given as 0.1 microfarad. The off time comes out to be using this equation. Now you can see, since RA is more, the off time is more compared to on time. The duty cycle is actually 1 minus this. So let me just slightly modify this duty cycle.